Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 E295. We're gonna be overflying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport. Runway 14 for our night is localized and landings around the cockpit for the pre-takeoff evaluation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments and displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display. The display is how the airspeed indicated. The airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure of the outside atmosphere, and the target altitude selected from the autopilot flight director system panel, the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute. All the steepness of the trigonometric angles increasing at climb descent. We have also the artificial horizon with the attitude indicator, the pitch slattery decrease, and the bank angle in decrease. The angle of attack of the aircraft as it flies, and the ILS localizer. We have the ILS localizer, which is the instrument landing system of its airport runway threshold antennas that transmit the radio frequency we receive with the onboard antennas of the aircraft. So we have a unique radio frequency for each runway and its head. We have determined the radio frequency for the specific airport and runway, and set the magnetic north pole heading. So we have the runway 14 in LSE, Zurich International Airport in Switzerland. So I'm gonna set the runway 14 136 degrees heading, and its ILS frequency, the ITL. So you will see it later displayed in the primary flight display. We're gonna select the radio frequency from the flight management computer or manually from the radio management panel. So we have also the ILS localizer. You will see the horizontal localizer and the vertical glide slope, which will align us with the runway heading, and also the angle of approach, the glide slope. So we have also the ILS localizer crossbars displayed in the primary flight display. We have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have the angle of attack of the aircraft as it flies in the flight mode, balanced here with the autopilot and the autothrottle. Later on, vertical navigation. We have also the HSI, the horizontal situation indicator, that displays the magnetic heading and track, and also the display of the waypoints we have to fly through. So you will see the flight plan when we're gonna create. It will display the purple line, that's the line, also the color. So you'll see also in the navigation display the flight plan we're gonna create departing from the runway, and also making some turns in the air. We're gonna cross through some waypoints, some stars. So you'll see displayed in the navigation display, and altitude and speed constraints. And then we're gonna descend for approach and landing. You will see the whole route of the aircraft. So we're gonna have also we have the navigation display that displays the horizontal vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar displayed with red, green, and amber or yellow indication depending on the distance and the altitude difference from our aircraft. You can see the terrain. Also you can see the sea, the lakes, and the rivers with blue. You can see the terrain map, which have the airports are displayed with a 4-letter account name with blue letters and symbols. So you can see the aircraft in the airport we are located right now. You can see the runways we're gonna use for takeoff and for landing. the heading of the runway, also the taxiways we're gonna use. So you can see also the navigation aids. The nav aids are displayed the work stations, ADFs and DBs. Also we have the waypoints which are horizontal vertical navigation fixes and altitude and airspeed constraints. The aircraft is gonna have to fly through some waypoints. As you're gonna select the flight gun, and they're gonna be connected with the purple remote Z line. Again, you're gonna see also we have the vertical distance above the ground. You can see the horizontal and vertical over here. As you can see the primary flight display and the navigation display here. You can see the terrain, red amber color, the terrain elevation right now 4,600 feet, 1,600 with the other color. So red color is 4,600 feet for the distance of 80 nautical miles in front of us. With this arc opening, you can see also the airport we are located, the Zurich over here. This is Switzerland. Here is France. Up here you can see Germany. We have Düsseldorf over here, DTL. You can see also the altitude we're gonna be flying above the ground level in thousands of feet. So you can see the terrain below you, the mountains we're gonna have. So we set the range in a closer distance like this. You will see the mountains, the terrain. Also we're gonna see the runway later. We're gonna use for takeoff and for landing. So close we're coming in. You can see now we have again some mountains over here in front of us. And the more dense terrain. Over here, yeah, you can see better. So here's the mountains, here's the altitude. Right now 1,400 feet here. We're gonna be flying higher, 4,000, 2,000, 4,000, 6,000, 10,000 right now is displayed over here. Same like in the autopilot direction system panel. We have selected 10,000 feet here, also 200 knots airspeed, 360 heading. The vertical speed also. This is the autopilot panel. So I'm gonna show you also the autopilot panel. You will see over here again 80 nautical miles over here. You can see all the way to Düsseldorf. You can see further away. Also the primary flight display over here. I will talk to you now. Also in the navigation display. Also we can see other aircraft that fly around our own aircraft. Using the transponder, there is been the AC transmitter receiver, transmits our frequency to other aircraft in the air traffic control and receives from other aircraft and can display. You can calculate using the radio frequency, transmission and reception, the other aircraft distance, where they are located, the bearing from our aircraft, the altitude difference from our aircraft, how many tens, hundreds and thousands feet are above or below. Also, you can calculate whether they climb or descend with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning if we have an incoming collision, so we'll make an avoidance maneuver in the air using the TICA system, the traffic collision advisory system. You can see also the other aircraft are displayed with a diamond shape. And we have an incoming collision. It's displayed with amber, yellow or red indication. And we have the TCAS warning. We have also the display of the traffic in the taxiways and the runways in the ground. You can see other aircraft. So we have also, you're gonna see here, I'm gonna show you the flight controls I'm gonna use for controlling the Boeing 787 over here. So we're gonna make climbs and descents, use the elevator, the control column of the yoke of the Boeing 787 to climb and descend the aircraft. So it's the side stick. You can see I have the side stick from the Airbus. You use climb descend. It's the same principle like in the Airbus and the Boeing aircraft, no difference. You just use our control wheel, left and right. Side stick in the Airbus is the control wheel. In the Boeing, left and right turns. So you see also, you can see we have the rudder pedals like in the Airbus and the Boeing. You control the vertical tail, the rudder, and also the nose wheel steering. You can control the forward nose wheels of the aircraft to make left and right turns like 76 degrees. you use the forward nose of the aircraft, 76 degrees. You can see here 76 degrees deflection left and right over here, and also the rudder. And as we increase the airspeed for takeoff, it decreases to like 7.6 degrees left and right, and we have more rudder aerodynamically effective. So you can see the rudder here, you can see elevator, climb, descent, make turns left and make turns right over here, ailerons and spoilers. So you see all flight controls, movement. So I'm gonna show you now the outside view of the aircraft and talk to you about the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for the air transport pilot license and the commercial pilot license. You will see how we control the aircraft. We need to know the aerodynamics and the forces of flight. So how we're gonna use the flight controls and the flight dynamics for controlling the aircraft in flight. Also gonna see the thrust levers I can control over here, also using the thrust control over here. So I can move the thrust levers forward enough. You will see the position of the thrust levers, and the engine thrusts are commanded over here in the ACAS engine indication controller system display. You can see the engine's indication for takeoff. You can see we set the takeoff power will give us some warnings that we not configure now for takeoff. Configure flaps and spoilers, so we're not ready to take off. So I will show you now the outside view and talk to you about the aerodynamics we need to know. So you can see the outside view of the aircraft over here. You can see the surface area of the wings hold the weight of the aircraft as we fly. We divide the surface, the weight over the surface area to find the lift created by the wings. The lift is the force that lifts the aircraft in the air. We have the thrust vectors from the engines, the propulsion of the jet system over here that move the aircraft forward. You can see here we have the cones from the exhaust of the engines. The jet blast. So we have the high pressure compressor and turbine here, and the high speed shaft behind, and also we have the low pressure compressor and turbine and the low speed shaft in the front. The fuel burn. We have also the bypass air. This section bypasses air from the front fan. We have also the fuel run lines over here to the engines, also wing and engine at the eyes here lines. So we have the left wing and the right wing tank, fuel tank. So we have right now 30% in the left and 30% in the right wing, and 10% in the center tank of the aircraft. We have the mean aerodynamic chord over here. The Mach, which is 23% of the mean aerodynamic chord of the wings, is where the maximum aerodynamic lift occurs in the wings. Also the center of pressure is moving back and forth as we fly. So we have also the airflow becomes detached from the top surface of the wings as we fly for a given angle of attack and airspeed. This is the stall speed, where the airflow becomes detached and the aircraft wings stall in the air. So we need to pay attention when we fly. Over here in the airspeed tape, you will see the airspeed indicator. The airspeed indicator over here, you can see the stall speed display with a number yellow and red indication. So I will say later you need to apply the thrust, more thrust, full thrust, and push the thrust, push the yoke down, or the thigh stick of the Airbus, the yoke of the Boeing, to pull down the nose, decrease the angle of attack. So this is the stall avoidance. So you can see the mean aerodynamic chord position where the maximum aerodynamic lift occurs is also the position where the center of gravity is located down here for the aircraft, where the fuel also is located, the left and the right wing fuel tank and the center tank. So also what the yawing axis is, the vertical axis of the center of gravity. So we use the rudder for making left and right turns, stabilize the aircraft in the air or on the ground using the rudder through the yawing axis. So we use the rudder pedals here for the rudder. You can see, make left and right turns using the rudder pedals. We have also the toe brakes in the rudder pedals and the nose wheel steering. We control the tiller. It's interconnected, like so like that. So the left and right rudder pedal is the rudder here, right or left, like this, as you can see. Also, in the ground, the rudder becomes aerodynamically effective at 45 knots or 70 kilometers an hour in takeoff. So we have the nose wheel steering here. The nose wheel can turn left and right like 76 degrees using the rudder pedal. So the tiller in the ground from 0 knots airspeed to like 45 knots, we have the rudder coming in, aerodynamically effective. So the left and right nose wheel, it decreases to like 7.6 degrees from 76. Then as we accelerate to like 80 nautical miles per hour, we have the rudder only become effective like 144 kilometers an hour. The nose wheel steering is locked to 0 deflection, it decreases to 0. So we have only the rudder aerodynamically effective above 144 kilometers an hour. We have no longer the nose wheel. So in takeoff above 144 kilometers an hour or 80 knots, we have only rudder, no nose wheel. Also in landing, it's the inverse as we decrease the airspeed. So we have the rudder pedals, the nose wheel steering over here, the tiller, and the brakes of the aircraft, normal braking. So you can see also we have one more axis here, is the lateral axis from wingtip to wingtip, from one wing to the other tip. It's the axis where we have the pits of the aircraft over here. So we use the side stick in the Airbus for the pits. We pits up and we pits down, back and forth. The side stick, you can see back and forth. The Boeing is the yoke, back and forth. So back and forth the side stick in the Airbus, climb and descent. You take the weight up and you climb, you pitch the nose up, and you take the weight down and you descend. So it's the same principle in the Boeing and in the Airbus aircraft. Just use the side stick in the Airbus and the yoke, your yoke in the Boeing. Same thing, same function. Also the control wheel, I will show you now. We have one more axis, the longitudinal axis from nose to tail of its aircraft. Is the longitudinal axis is the side stick left and right in the Airbus. You make left and right turns like this. It's also you can see left and right turns. You use your ailerons, spoilers in the Airbus. We use your ailerons, spoilers, and flaperons. You see we have one flaperon here in the Boeing, in the left and the right wing. So same thing, you use side stick left and right, ailerons and spoilers, make left and right turns using the wings, left and right wing differential lift when you make the wings up and down, ailerons and spoilers, side stick left and right in the Airbus. Also control wheel left and right in the Boeing, make left and right turns, deflections. So this is the explanation. You can use all flight controls together, full movement, just like in the Airbus, and also in the Boeing you have full flight control, coordinated flight. Also you can see the Boeing there, the flight controls move together, they're interconnected, both the captain and the first officer. Unless you want to override one side, you use more force, or if you have a failure, you override again using a force to control more one side than the other. Also you can see in the Airbus we have the side stick priority button over here. We take either left and right side priority. if we need priority left, priority right. And we have the autopilot disconnect. Also we have both dual input for the Airbus that adds and divides the sum of forces of deflection, actually side stick deflection. So we have also the pilot disconnect and push to talk for the Airbus aircraft over here. The side stick priority, autopilot disengage for the Airbus, and push to talk. This is the Airbus aircraft side stick. As you can see, I will show you better. So keep seeing you showing you the flight controls over here. So we climb and we descend the elevator or flight controls together. Full flight controls movement. So this is the basic of the aerodynamics. Then we go for full flight, see the rest of the systems. So we have one more thing to look at the aerodynamics. You see the bottom surface of the wings of the aircraft is more flat, and we have the flaps extended. Also we take positive angle of attack for takeoff. We have as we accelerate to like 250 kilometers an hour, we have higher lower airspeed below the wings, lower airspeed, so higher it's air pressure, which pressurizes the aircraft weight and wings up into the air. Also you can see the top surface of the wings is more curved, higher curvature, so the airflow is moving much faster above the wings, which creates lower air pressure using the Bernoulli theory of fluids, which creates lower air pressure and higher pressure below the wings, creates the aerodynamic lift, which sucks the aircraft weight and wings up into the air. So we have a few more things to see. You can see as we climb and descend the aircraft in the Airbus, we have the trim wheel. We can trim the elevator up and down, either manually or the auto trim. We have the flight control computers. We can also trim in the Boeing aircraft. We have over here these trim suites. You can see we use the trim suites. We have the flight control computers over here. This is a fly-by-wire aircraft. Primary flight control computers in the auto position over here. As you can see, we have the air data also computers over here, heading reference, flight control surfaces. So this is flight control computer. And as in the Airbus, you can make climbs and descents. You have when you have a fly-by-wire aircraft, you have the flight control computers. Same like in the Airbus, you make left and right turns like 2.8 G, left and right turns. The G, the acceleration of gravity, or 67 degrees of the side stick deflection, left and right. It's limited in the Airbus aircraft, 2.8 Gs, left and right turns, or 67 degrees maximum side stick deflection. You have also in the Boeing similar things. Also climb and descent in the Airbuses, 30 degrees climb and 1.5 Gs climb, and minus 15 degrees or minus half Gs of descent. The G acceleration of gravity. So also you have other protections, the alpha floor protection and speed protection. So you have in the Airbus, the Boeing similar things. You have flight control computers. You have also the auto trim, the automatic trimming, both in Boeing and in Airbus aircraft. The flight control computers will balance the aircraft in flight using the horizontal tail elevator balance trim, or the stabilizer, the whole tail stabilizer trim. So we can use the manual trim both in the Boeing aircraft and the Airbus aircraft, no difference at all. So you can see here we have I have these buttons for the horizontal trim stabilizer. I have also for the Boeing here the balance of the stabilizer trim. So you can trim the elevator over here. You can see elevator trim over here. So elevator trim, left click down, right click up. Left click down, right click up. Over here you see this the tag, what it reads. So you trim the elevator up this way, it fits the nose of the aircraft. You have this aerodynamic effect, fits the nose of the aircraft up, and when you trim the nose, the elevator down, it fits the nose down of the aircraft as you fly. So you use this to balance your aircraft in flight using manual trimming to relieve the air pressure from the flight controls as you fly. You make less effort with the control when trimming right the aircraft. So you can see also we have the flap speeds over here displayed. We have you can read again, elevator trim, left click down and right click up. We have also the autopilot disengage over here, the switch, and the head up declutter over here with declutter. So we have also we have this is the normal control, normal channel of the flight control computer. So you use the side stick, climb, descend. Also trim the elevator properly when flying will make more easy flying. So you have the normal channel, you have the alternate channel of the trim over here. You can see how many degrees you have trimmed your aircraft in flight over here. 4.29 4.5 degrees right now, 4.50. Nose up, nose down, stub here, stabilizer, nose up, nose down. So the green band is for takeoff. We have the rudder trim also here, zero deflection, the flaps. Other settings are the engine's indication, also the landing gear, extend and retract right now. So we'll see later, landing gear, extend, retract. Alternate gear over here, lock override. Also the auto brakes system here. You set rejected takeoff or auto brake 1, 2, 3. Auto brake RTO. So I'm gonna show you the stabilizer trim, very important. I'll show you the manual, the normal channel of the flight control computers. We have also over here the alternate pitch trim. You can trim alternate. You see elevator trim, alternate pitch trim over here. So this way you trim the elevator up, you pitch the nose up, and this way you trim the elevator down, you pitch the nose down. So you need to remember this way you trim the elevator up, so you trim up, you trim down to balance the aircraft in flight. Also you have the parking brakes here, on and off, as you can see, parking brakes pull. So this is the nose elevator. Also we have communications here, satellite, VHF, very high frequency with the radar transponder, ground proximity. We can tune other frequencies if we need. So I will show you also this panel. And we have the fuel control also for the left and right engine. So also now we have this stabilizer cutoff switch. This is if you have a failure, you can see. So if you have some failure of the hydraulic system, will affect the flight control computers of the Boeing aircraft to control the elevator with the auto trim system. You will have to disconnect this switch. I will show you now, the stabilizer cutoff switch, and use only the manual trimming after. So if you have a failure with the hydraulics system, which affects the hydraulics actuator of the tail of the aircraft movement, you can see here we have the hydraulics pumps here, primary, demand, left engine driving, right engine driving, also electric C1, C2, also the receive pressurizer, I will show you later, from the engines, from the APU. We're gonna have malfunction of the flight control computers, and this will have, with the grade from normal, we have the normal, the alternate and the direct low of the flight control computers, like in the Airbus, also the mechanical backup. So it will degrade down the flight control computers function. So you will lose the auto trim from the autopilot and flight director system panel over here, as you can see. So we come down here and we open this. You see it's for all Boeing 737, Boeing 747, Boeing 757, Boeing 777, and Boeing 777 and Boeing 787. You open from normal over here to cut off these switches, as you can see. stabilizer cutoff, and you use only the alternate here pitch trim. You lose the automatic. You use the alternate and also use the manual pitch trim. So you trim the aircraft up and down, the elevator of the aircraft, and you use also the manual switch over here to trim the aircraft tail all the time. So we have here the trim switch, as you can see. You check again from the stabilizer trim display over here, nose up and nose down, 4.5 degrees. So we climb with the sun. We use the stabilizer trimming over here, as you can see. I will show you one more view of the flight controls of the aircraft. We have also the engines here at the flaps position. We can move the engines forward. You will see the flaps extend like this, or retract flaps position, how many degrees you like them, extend or retract, or 0. We have the speed brakes also, extend or retract. The thrust reverser over here for the engines, the auto throttle. Disengage, you press this switch, is auto throttle. Disconnect, as you can read. Disconnect switch, take off, go around over here. Left and right engine, thrust reversers for the engines, and also the fuel control, left and right engine, fuel valves on and off. Cut off, you have the fire extinguisher, left and right engine, pull out and switch, the transporter for viewing the other aircraft in the air or in the ground. Radar trim here, so this is radio management panel. I'm gonna show you also one more view of the flight controls of the aircraft over here. So we have I'm gonna show you one more view of the aircraft flight controls of the Boeing 787, then I'll show you the rest of the systems, of the pilot flight regular system panel, primary flight display, the engines indications, also the flight management computer. We're gonna set it for the flight plan for takeoff and for flying. So I will show you now the one more view of the flight controls of the Boeing 787. So hope you can see again, we have the full setup here. The computer, as you can see I'm having this. The mouse also we need for controlling the keyboard over here, and now the screen. Also the side stick, which is identical to the Airbus. So you can see also we have one more nice view over here. So you can see we can again move the side stick up and down, climb the aircraft up and down when we fly. Also make turns to the right, make turns to the left. You see the flight controls movement. You see also we have the thrust over here control. We move the thrust levers up and down. So this is the thrust control also. Again one more time. Thrust control, and also hope you like it. We have left and right. The side stick deflection is proportional, as you can see, to the yoke deflection. Better view like this. So you're gonna see later when we fly how I'm gonna control the aircraft flight controls, make left and right turns over here. So you can see we have also an aircraft is coming in for landing, a Boeing 737-800 over here. So you see it's coming. So you climb and you get descend like this, the elevator up and down, the trim of the tail over here. Hope you like my side stick, which is identical to the Airbus side stick, as you can see. move all the thrust levers up and down like this. Control all the thrust of the aircraft up and down, forward and aft. So we have the full control, flight controls system, left, right and left turns, as you see, side stick left and right, or yoke control wheel left and right in the Boeing, side stick in the Airbus, also climb and descend, the elevator, side stick in the Airbus, climb back and forth, or yoke in the Boeing. So we have all flight controls. Also we have over here the outside view one more time, then we go elevator up and down, rudder pedals over here, and nose wheel steering with the rudder pedals. Also ailerons and spoilers one more time, and flaperons in the Boeing, side stick left and right. So this is all for the flight controls, I believe, right now for tonight. I'm gonna show you now the rest of the systems of the aircraft. We go for the flight, so we need to see the displays also. See you later in the flight. Now I will show you the primary flight display, autopilot, director system panel setup. I will set up maybe first the flight management computer. I'll set up the flight plan for this flight. I will input all the data of the aircraft for this flight, the takeoff gross weight, that includes the passenger plus the cargo plus the fuel on board, where the fuel is stored on the left and the right wing in the center tank. The flight management computer is going to calculate from takeoff the center of gravity. Also the mean aerodynamic core position with maximum dynamic lift occurs and the stall for given angle of attack. Also the flight management computer is going to calculate, because we're gonna use 15 degrees, 15 degrees of flap. It's going to calculate the horizontal tail trim stabilizer position, 4.25 degrees for takeoff, and it's going to give us also the takeoff speeds V1, V8 and V2 for this runway. So the flight management computer calculates the center of gravity, the weight of the aircraft. Also, as we fly, we burn fuel, and the center of gravity is recalculated every second. Also, because we change the flight, because it guides the flight management computer, the autopilot flight director system panel, and the flight control computers. Also, we have I'm gonna set the takeoff runway, the Zurich International runway 14. The runway length, the runway slope, the wind direction, speed, the barometric pressure, the density of the air, and the temperature of the air, and also the runway conditions. If you decide to fly what, it will give us the takeoff speeds V1, V8 and V2. We're gonna use 99, 100% of takeoff thrust power in pitch altitude, like 9 degrees for takeoff. So we're gonna have the seeds, the SADA range with departure waypoints and fixes that include horizontal and vertical navigation fixes, and altitude and airspeed constraints for the initial climb and departure of the aircraft. We're gonna climb to the cruise level at 25, 26, 27, 28, 29, 30,000 feet. Above the sea level, we're gonna cross through some waypoints, then we're gonna initiate the descent back to the airport from the cruise level, like 7 or 6,000 feet. Above the sea level, we're gonna align with the stars, the SADA terminal arrival waypoints and fixes that include horizontal vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing of the aircraft. Also, we can be aligned with the ILS localizer, the horizontal localizer, and the vertical flight slope that receives radio frequency transmitters from the first order and the antennas with a unique radio frequency. For this one, we're going to be aligned with the magnetic north pole heading of 136 degrees for approach and landing with this runway. Also, we're going to be having the ILS localizer too. We're going to be having about 60 or 70% of thrust commanded from the engines, about 270 kilometers an hour airspeed for approach, about 160, 170 knots or nautical miles per hour. And then we're going to be having 25, 30 degrees of flaps extended, and also pitch altitude 9 degrees or less for landing, and then landing gear extended. So you're going to see the complete flight from takeoff, climb, cruise, approach and landing in the end part of the video. So stay with me until the end part to see the complete flight. Now I'll show you how I can control here You can see I'm having again the computer, the mouse pad I'm using here, and the keyboard to input all the data I need into the screens, the flight management computer over here. So we go over here, you can see I can use this mouse pad here, the screen, left, right, the touch screen, and also the flight management computer. We need to create the flight plan here. So you see over here we can change the views, select modes, takeoff, approach, announce its status, performance, flight plan. So we're gonna set here from this view over here. So we see again the view of cockpit from this view. So we select the identity of the aircraft, Boeing 787 here, Iraq cycle, GNX engines position, LSZ8 airport. We can align the IRS, let's see, the inertial reference system, the coordinates, longitude and latitude of the aircraft, the index performance here, zero fuel weight plus fuel on board, gross weight for takeoff. So we have zero fuel weight to 322.7 thousand pounds plus fuel on board 33.4, to gross weight 355, cruising altitude, cost index, fuel freezing temperature, cruising center of gravity, and reserves in flight. So we use the route LSZ8 Zurich International Airport here, copy paste, back and forth. So this is route 1, clear the discontinuity, set runway over here, departures and arrivals. So we can select the runways for departure, runway 10, 14, 16, 28, 34. Over here you can see the runways we have on the right side. So we select runway 14 and the seats, the other instrument departure here, Zurich to Alpha. So we select the arrivals now. So we can select arrival 16, 28, 34 ILS, 14 ILS, 16, ILS 28, ILS 34, ZLS 14 localizer, 28 localizer, 34. So we use ILS 14 Trans Amity over here, and Trans Zui. The stars is other terminal. Arrival waypoints and fixes over here is the Negria. Departure arrival. So we have all the legs now are created for this route. So we have the first waypoint, heading of the runway to nautical miles 1900. Then we climb to the Zui, make left turn Negria here, 26 nautical miles. Zui descend, approach and landing, approach Zurich 701. So we initialize here. It's not yet activated. It's displayed with blue. We need to activate the route. So we use the zero fuel weight fuel on board and reserve. Gross weight for takeoff, flight altitude 25,300 feet over here, cost index of flight 100%, and fuel freezing temperature and cruising center of gravity. So we have the route now, can be execute and activate. The legs you can see with white and purple over here displayed with a purple color. So we have first waypoint 136 degrees, 2 nautical miles, 250 knots, 1900 Zui. We make left turn, 1 nautical mile, 3 nautical miles, 5 nautical miles, 6 nautical miles is the Zui. 301 knots, 6000 above the sea level. Negria 071 heading is 26 nautical miles from Zui. 301 knots, flight level 22,200 feet or 7,000 meters above the sea level. Native. Make a right turn 12 nautical miles from Negria, 320 knots, 11,800. So we descend Amity 6 nautical miles, Zurich 9 nautical miles, Zurich 701 6 nautical miles from Zurich, TRA 110 nautical miles, CI 14 6 nautical miles. Then Osenham we make a left turn here 5 nautical miles from CI 14, 174,000. Runway 14 over here, approach and landing 8 nautical miles, 144, 1,400, and also takeoff, go around if we need to go around. Flaps 15 degrees, center of gravity and trim 23%, 4.25 degrees. Takeoff speeds V1, V rotate V2 for this gross weight and the runway So we have also other things to see: alternate VNAV, progress, FMC communication, hold, we can hold over in flight, use fix, and also the navigation radio we can tune from the flight management computer, ILS localizer, and a VOR ADF. So we go back over here. We're almost ready for takeoff. We need to set over here the lights, and also turn the APU on because it's getting dark. So we'll still have the APU start. We need to start the APU. You'll see how we're gonna start the engines in the electrical panel. So you can see the displays again over here. What the display, you can see the airspeed indicated here, the airspeed tape, the selected, the altitude selected, the pitch ladder in degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5 degrees, pitch up and pitch down, the bank roll of the aircraft as we fly, like 5, 10, 20, 30, 45 degrees left and right. Barometric altitude above the sea level, 1,430 feet over here, and the barometric pressure is 29.92 inches of mercury, 29.92 inches, you can see, and the radio minimums. We have also the radio altitude above the ground, so the barometric pressure we can set here. You can see barometric pressure, inches of mercury, 1013 hectopascals, or inches of mercury, 29.92. Minimums, radio baro, plan, map, display, the range, weather, radar, traffic, terrain, accept, cancel, reject. Over here also the systems display, CDU, info, checklist, communication, navigation display, engines, left and right, display, expand, or see other things in the display. You can see also the flight plan now we have created over here. So we have the barometric pressure set, also the ILS. Here and here we have the vertical climb of descent of the aircraft. You can see like 500, 1000, 1500, 2000, 3000, 6000 feet for climb and descent. So you have all the altitude, the airspeed, very important. Also you can see the maps here that we have displayed how far away you want to see the flight run, and now the aircraft symbol, also the terrain, map setting over here. This is for navigation of the aircraft. Also you can see over here we can see the runway now we're gonna use for takeoff, and the taxiway in front of us, the other runway, also the terrain in front of you when you fly above the ground level. So we look in front of us, we see our own taxiway and the aircraft symbol, the runway we use for takeoff and for landing. So you look outside, you see same things for navigation, the taxiways from the GPS receiver, the runways, other aircraft that fly around us. So we expand, we see further away, also the terrain, elevation, the waypoints we're going to be flying through. So we need also overhead panel again, very fast. You see we have the left and the right at Z, the gray generator, 120 to 200 volts, 400 Hz frequency, the battery, 130,000 kilovolts from left and right engine, primary flight control computers in the other position, air data computer, flight control surfaces, the battery, town power, FT door, passenger oxygen, window heat over here. Also rammer turbine, left and right engine driving, hydraulic pumps, primary in demand. In the off position you will see the fault display. Also we have the engine driving, the electric back to the on. So we have also fire, the recorders, fire extinguishers over here, cargo and APU, electronic engine control for the engine that control the engines, normal and alternate. Start here, we can start the engines like this in the start mode. We have the fuel jettison, we can dump some fuel here in flight. We on this and select the nozzles and how much to remain. Make an emergency landing. We have the fuel over here. left wing, right wing, and center tank. The crossfeed valve is solved with any tone. You can feed either engine with either pump or either tank and balance the fuel between the left and the right wing. So we use back to the on. You see the valve light also. So we have the pressurization here, wing and edging at the eyes over here very quickly. On and auto, back auto. Pressurization here, outflow valves position, climb descent, manual and auto. Bleeder from the engines and from the ABU, oxygen regulation, hydraulic fluid tanks, pressurization, wing and edging at the eyes. So this is all we need to know. Right now we'll go back to the screens here, one last look. We have no time also for the engines and the autopilot, so we look very quickly. The hydraulics here, over here you see hydraulics, quantity, left, right, APU, oxygen, liquid cooling. So we have the electric left and right engine drive and IGT, the APU is running, the battery, voltage and the load cell. Over here 31 volts and the upper edge of the batteries. So we have hydraulics, where the hydraulic fluid goes, which systems use hydraulic fluid. Also left and right engine drive and primary demand, electric C1, C2, hydraulic fluid tanks, quantity and pressure 5100 psi. And now also the fuel, we have the left and the right wing fuel tank and the center tank. You can see the crossfeed valve is solved but with an tone. You can feed either engine with either pump or either tank. So we have the low high pressure fuel valves open, feed both left and right engine. We have 11,000, 11,000, 10,000, total 32,000 or 30%, 30% and 10% of fuel. The APU is fed from left wing using the DC motor over here. So you can see forward and aft fuel booster pumps. Also we have the minimum fuel temperature over here. You can see minus 37 degrees, below which the fuel will freeze in flight. So we have to recirculate the fuel automatically from the Farex. We recirculate the fuel. You see minus 37 in freezes, the fuel temperature right now. So the Farex control the recirculation of fuel from the tanks into the engines components, also the lubricant and the oil. We have the air pressurizer from the engines for air conditioning, oxygen. The doors are closed, the cabin can be pressurized. The gear, you can see the pressure of the tires and the temperature of the brakes. Flight controls over here. You can make left and right turns over here. You see the flight controls. Deflection, tails, climb descent, rudder pedals also. Stabilizer trim, FS display over here. Maintenance over here. Circuit breakers, maintenance also is automatic from digital display. The checklist also. We have the normal checklist before start, after start, before takeoff, after takeoff, descent, approach and landing. Over here also communication, so we'll go back. Navigation display over here very quickly. We have quite a few seconds to turn off both engines. So fuel control over here, both in the off position. You see fuel starvation over here, and the messaging from the engines, fuel off and power off. So we see we have a few more minutes to go for flying, couple more minutes. So you see here, so we need to restart the engines very quickly. Auto start both in the on position, start valves, auto start over here. You see the recirculation, the reconfiguration actually of the amber colors. So we have pressurizer only in the N2. This is the N2, the high speed and high pressure compressor in turbine. We have the N1, which is the low speed starters, have low pressure compressor in turbine, the exhaust gas temperature. So we need to let the fuel flow now on over here. As you can see, we have only pressurized air right now. So we let the fuel control on like this. So you see now we have the N1, the exhaust gas temperature, fuel flow also, oil pressure, oil temperature, oil quantity and the vibration of the engine. We have also the cabin pressurization, so the auto start is kicking in here. We have the hydraulics on, so N2 is the high speed starters have high pressure compressor, and turbine with the turbofan 2% engine, and 2 low speed starters have low pressure compressor and turbine of the turbofan turbojet engine. So we have both engines here running. We can go for takeoff right now. Flap set for takeoff. Speed brakes up. Also the autopilot setting, we can see auto throttle left and right, on and off. We have the LNAV here, the airspeed. Select the airspeed. So select airspeed, flight level change, LNAV, VNAV over here, flight director on and off, very important. So flight director back on. The heading over here, and bank angle setting. So we set the heading 136. The vertical speed you can descend over here or climb like this. And also the altitude we can set. So this is all we need to set for flying the aircraft. Parking brakes off, advance the thrust levers and go for takeoff. We take the air traffic control clearance from the tower. So the runway is open for us for takeoff. We have no incoming aircraft. We can taxi into position for takeoff very quickly. Also use the tiller for nozzle steering. So you see how you use the tiller. So advance the thrust levers over here, takeoff, go around full takeoff power, align with the rudder pedals, and push the yoke down until 80 knots, 80 nautical miles per hour. We need to push the yoke in the Boeing or the side stick in the Airbus. So we have 90 knots. Let the yoke off. 120 V1 over here. 130 we rotate so it picks up slightly, 9 degrees or less. So this is the takeoff, pitch up and takeoff, positive rate of climb, land gear up. Σε 12 λεπτά τελειώνω. 12. 14 βασικά. Θα τελειώσω 14 λεπτά και θα πάω, εντάξει. So we have here, you can see the display. We are 2000 feet above the ground level. The airspeed indicated 173 knots. You can see the terrain, red, green and yellow indication. We climb 4000 feet per minute. We are 5000 feet rate of climb over here. You can see the trend lines and the pitch altitude 20 degrees. So you can see around you as we keep climbing over here. You can see also the engines indications. You can see closer the terrain over here. So you see we are like 4000 feet above the ground level. You can see the terrain below you. We are 4000 above the ground. This green line is the terrain below you. So we see again the airspeed, the stall speed, red and yellow, the wind direction and speed. So we have the outside view as we're climbing here. We need to make the turn, the runways over here. So now we make the turn here. We have 13 more minutes for the video to end. So we make a turn here. can see we climb here, depart the runway. So hope you like the view of the aircraft as we're climbing over flying the Switzerland. So we have a beautiful view, the galaxy, the airport, the Swiss Alps, the lakes over here. You can see the Boeing, the aircraft. Also gonna see the Germany in front of us and the France gonna be overflying. Very close. So this is the views here. Also the aircraft, the Boeing aircraft. So we need to continue now. Have a couple more minutes for starting back the turn for the airport. So keep climbing here. So you see the airspeed, stall speed with yellow and red, the flaps speed over here, the pitch attitude of the aircraft, and also the wings level, the wind direction and speed, the waypoint, the intercept 3.4, the Zui, we have to fly through the Zui. You can see the ground speed of the aircraft here, the altitude 16,000 feet, also the autopilot settings over here, the engines indication, and the other side over here display. So you can see the whole flight plan here, how far away we're gonna be flying. So we have a few more seconds to make an alignment here as we fly. And align here with the flight plan and make the turn now over here. Align here with the flight plan, as you can see, as far as we can right now as we're climbing. So we have a few more seconds. So you can see the France here, the Germany, my homeland in front of you, the Bayern, Munich, the France, the lakes, and the Switzerland. So we're going back. So we use a rudder, right rudder right now to make a steeper turn as we turn here back to the airport. Full thrust over here. So you can see the turn over here as we're turning, and the outside view also. So we are overflying the Germany here, the Bayern Munich. So beautiful aircraft view over here. So this view. And we're going back to the airport. We need a couple more minutes. Align over here with the flight plan again one more time. Use right rudder pedals. And also we need to increase the airspeed in a couple of minutes. So we are aligned here. So we're going to be having the chemtrails in a couple of seconds. So here we have the chemtrails, frozen vapors over here. So hope you like the frozen vapors from behind the aircraft, the exhaust of the engines, and a beautiful galactic view over here. We're flying here the lakes, the Germany behind us, the Bayern Munich, and the France. So we're going back to the airport for landing. As you can see, we have now to start the descent now. We are overflying the runway's position, so flaps up, idle thrust, speed brakes extended. So we need to reach the runway and the airport very fast. You can see the runway here. Also the cockpit one more time. As the descending here, the aircraft will descend. It's a little bit more less idle thrust now as we are descending. You can see the Mach speed here, 0.65, 0.73, so we have to cross through these waypoints, approach for landing. Also the other side over here, indications, so you can see. So we need to start turn now for approach and landing over here. So we start the turn, keep descending. So this is the turn for approach and landing. It's a little bit more rather. So here we are descending. Keep descent over here and have 3 more minutes for approach and landing. So we have the runway position here, keep descending, align with the runway heading over here, landing gear also down. We need to keep turning a little bit more, keep descending. We're going to be aligned with the runway position here. So we have the runway inside as we are descending, landing gear also down, flaps extended here. I'm gonna and the flaps almost fully over here. Align now with the runway position here as we are approaching, and we're gonna be having also the outside view for landing over here. So we have some side wing and some wind gusts that we need to align with. You can see the runway here we are approaching. So we have also the ILS localizer. We need to use the ILS localizer for alignment here with the runway. All the information that we need. So again, some wind gusts over here, side wind. Use a little bit more engine thrust over here. So we're gonna make it. Wind gust, we need to use left rudder now, right rudder sometimes. Also ailerons and spoilers. For alignment with the runway position, as you can see. We need to use a little bit more idle as we are approaching for the flare. We align again with the runway center line over here. So we have the flare here, flare, touchdown, very beautiful, touchdown, parking brakes, idle thrust and thrust reverser. Over here you see thrust reverse. So we align with the center line, and we're slowing down the aircraft. As you can see, we now slow down the aircraft, keeping center line. So you see the thrusts are reverse, slowing down, keep slowing. You see all landing gear is perfectly safe. There is no breakouts of any system of the aircraft. Also the nose wheel is perfectly safe. The aircraft is starting up the way it should be.